Hi, good evening, everyone. Today, we want to go ahead and we want to talk about multiple things. The first thing that I want to do is see what is the definition of net substitutes and net complements. We already saw gross substitutes and gross complements in the last class. Today, we want to talk about net substitutes and net complements. That's the first thing. Then we also want to go ahead and we want to talk about what is the way of decomposing the Slutsky equation. How can we write down the Slutsky equation? That's also something I want to do today. Post that, I also want to go ahead and I want to talk, if time permits, I also want to go ahead and talk about very, very important concept of compensating variation. Very important. Definitely one question will come in the exam, IIT GATE exam, in based on compensating variation. So we want to also go ahead and talk about that. To begin with, let's write down the definition of net substitutes and net complements. And net complements. So if you remember, right, in the last class, I had gone ahead and I had talked about what is the demand curve in case of compensation. So we talked about what is the difference between compensated versus uncompensated demand curve. We talked about this. We also went ahead and we drew these two demand curves. We said which is going to be flatter, which is going to be steeper. Ye pura cheez humne अच्छे से किया था. Then I told you that, whenever we talk about net, it is always going to be based on compensated demand curve. And that is why it is important to understand compensated demand curve. So based on that, let me write down the definition today. So please write down. Xi and Xj, they are called net substitutes if del Xi by del Pj is greater than 0. बेटा ये definition तो हमने पहले भी पढ़ी है. अगर प्राइस जब T का बढ़ता है उससे डिमांड अगर कॉफी की बढ़े, when price of tea increases, people shift towards coffee, demand of coffee increases, तो यही तो substitutes हैं. तो इसमें हमने अलग क्या किया? What's the definition? How has it changed? It has changed because now I am saying holding utility constant, which means that now I am talking about compensated demand. अब मैं सिर्फ और सिर्फ substitution effect में चेक करूंगी जो हमने compensated demand curve बनाया था, the demand curve which only showed the substitution effect for the Hicksian demand, right? For that demand, I will check whether this rule is applied or not. And if this rule is applied, then I will say that they are net substitutes. सिर्फ तब वो net substitutes होंगे. Only then they will be called net substitutes. So ये definition same है. This is exactly what we studied for gross also. But in gross, there was no condition. In net, I have applied an additional condition holding utility constant. So the moment I hold utility constant, beta, इसको हम better लिख सकते हैं. This is how compensated demand changes as price of the other good changes. And if this is greater than 0, then I will call them as net substitutes. अगर ये 0 से ज्यादा है, if this is positive, this moves in the same direction, then it is called net substitutes. Now let us look at the definition of net complements. Again, definition same है. जैसे हमने आज तक gross की है वही है. क्या है complements? When price of ink increases, ink is becoming expensive, but then pen also becomes expensive, so the demand of pen decreases. यही तो definition थी. So complements tell me कि एक के price बढ़ने पे दूसरे की demand कम होगी. Demand will fall. So this tells me how demand of one good changes as price of the other good changes. This should be in the opposite direction. ये complements की definition. But now, beta, I am going ahead and saying that this is net. And how do I say this is net? By holding utility constant. When I hold utility constant, it becomes the definition of net. So I am saying how the compensated demand changes as price of other good changes. This is negative. This is what the definition of net complement is. If you remember, the definition of gross, we proved, दो example के साथ, that the definition of gross is asymmetric mathematically. But now I will prove that the definition of net is symmetric, even mathematically. मतलब जो net की definition है, no matter which direction you apply, it will always be satisfied. हमेशा सही answer देगी. If it is net substitute, then x will be net substitute of y, and y will be net substitute of x. Both direction will give you the same answer. That is why net is more better way of analyzing the definition mathematically. Let's take the same example. So I will take the utility function ln x plus y. ये utility function है. But we know we can find x star and y star. What is x star? X star had come out to be P2 by P1, and y star had come out to be m by P2 minus 1. This is from the last class. I am not going to repeat this. You should know this. You can just equate MRS to the price ratio, and you will get x star as this and y star as this. Right? So x star was P2 by P1 and y star was m by P2 minus 1. Now, beta, what will be your utility? Utility will be ln x plus y. मतलब ये हो गया ln P2 by P1 plus m by P2 minus 1. This is your utility. How do we find Hicksian demand? Net के लिए I require Hicksian demand. Now, compensated means Hicksian. So for net, I need Hicksian demand. How do you get Hicksian demand? We have done this. You can find the expenditure function and then you can go ahead and you can apply the lemma, right? So you can just find the expenditure function. You can differentiate the expenditure function with respect to the prices, and you will go ahead, Shepard's lemma ke through, you will go ahead and you will get the Hicksian demand. So pehle to hame Hicksian demand nikalni hai. That's the first thing, right? So let's find out the Hicksian demand. So beta, let's find the expenditure function. If I take 1 here, I will have U plus 1 is equal to ln P2 by P1 plus M by P2. I can take this also here. So M by P2 is equal to U plus 1 minus ln P2 by P1. I can also open this if required. Huh? Isko open karoge to what will you get? ln P2 minus ln P1. ln M by N. So this will be U plus 1 minus ln P2 plus ln P1. This will be M by P2. So your M will come as U plus 1 minus ln P2 plus ln P1 into P2. This entire is your income. Income is nothing but expenditure. So income ki jagah pe expenditure likh do. So expenditure will be U plus 1 minus ln P2 plus ln P1 into P2. Now find the Hicksian demand. So Hicksian demand for good X, for good 1 will be, beta isko compensated bhi likh sakte hain. Never get confused. Compensated itself is Hicksian. The two things are the same. We have proved this in the last class. So when I talk about compensated demand or the Hicksian demand, this is for good 1 is when I differentiate the expenditure function with respect to P1. So if I differentiate this with respect to P1, P1 is only coming here. So ln P1 ki jo differentiation hogi, that is going to be 1 by P1 into P2. So that will be P2 by P1. Similarly, find out the Hicksian demand for good 2. That means I have to differentiate the expenditure function with respect to P2 beta. So P2 to yahan pe bhi and yahan pe bhi, which means I need to apply the product rule, or I can just write it like this: U P2 plus P2 minus P2 ln P2 plus ln P1 into P2. So if I just differentiate, what will I get? Differentiation of U P2 will be U. Differentiation of P2 will be 1. Yahan pe product rule lagega, so differentiation of the first function, second as it is. First function as it is, differentiation of the second function, plus ln P1. This is just a constant getting multiplied with P2. Right? Now just go ahead and just find out the answer. So ye ho jayega U plus 1 minus ln P2 minus 1 plus ln P1. This will be U plus ln P1 minus ln P2. These are the Hicksian demands. I have found out the Hicksian demand. Now, once you have found out the Hicksian demand, beta, now you have to see whether the net substitute or complement definition is being applied or not. So, kya karenge? We will ask how Hicksian demand changes as price of good 2 changes. How demand of 1 changes as price of good 2 is changing. So if I differentiate this with respect to P2, I will get the answer as 1 by P1, which is positive. And if I differentiate this with respect to P1, I will get 1 by P1, which is also positive. So I see that when I differentiate this or I differentiate this, I am going ahead and getting both of them as positive. Both of them are coming as positive. So they are going in the same direction, right? So we can write that both in same direction. And what is it telling me? That when price of one increases, demand of other is increasing, which means that net substitute. So beta, both of them, whether I am saying X1 is a net substitute of X2 or X2 is a net substitute of X1, दोनों से ही same answer आ रहा है. That is why this definition is more symmetric. It makes more sense mathematically, right? So this is what the answer is, that it is better to use the definition of net rather than gross. Okay. I hope this is clear to you, absolutely. Now, let us go ahead and talk about the decomposition of Slutsky. ठीक है, so इसको हम लिख सकते हैं derivation of Slutsky. This is one way of understanding it. The other way of understanding this can be relationship between compensated and uncompensated demand. So we need to derive the relationship between compensated and uncompensated demand. बहुत ध्यान से समझो. It's a little tricky. We'll go slow. If you remember, when I said that this is a compensated demand, a compensated demand curve is one that holds utility constant. So when we write this, it's a function of prices and utility. So we can say that compensated demand is function of prices and utility. In fact, it holds utility constant. If you remember the uncompensated demand, it was nothing but the Marshalian demand. And it is nothing but a function of income and prices. So it's a uncompensated demand. It is function of income and prices. Now think about it. The graph that we had drawn in the last class was something like this. Something like this, right? There was a point where the compensated and uncompensated demand curves were meeting. They were equal. दोनों से same demand आ रही थी. And what did we say? We said that that point such that you have both of them equal, इसका मतलब ये है कि बेटा जितनी income मिल रही है, that is exactly what I require to get this level of utility. और इस utility के लिए जितनी income चाहिए थी, that is exactly this. So the two are matching. If 100 rupees is the amount I require to get 50 utils, that is exactly my income today. And to get 50 utils, whatever money I require, I have exactly that money. So utility के लिए जितनी income चाहिए थी, you have exactly that. और उस income से exactly same utility derive हो सकती है. The two are exactly the same. So by definition, there exists a point such that XC, PX, PY, U is exactly equal to X, Px, Py, M. Both of them are equal. Please write this down. Very important. So by definition, the two are equal. It implies that the nominal income is exactly enough to achieve given level of utility. Right? I'm just writing in my words, but book language will be a little more formal. Okay. Now, let's come to one more step further. We know that income is nothing but expenditure. जितनी income होगी उतना ही तो खर्चा कर सकते हैं. We are always on the budget line. So income is nothing but the amount of expenditure that you do. And if you remember, when we write things in terms of expenditure, जैसे यहाँ देख लो एक बारी, ये हमने expenditure function बनाया था ना यहाँ पे. This is expenditure function, right? So when we write expenditure function, बेटा ये किस चीज का function है? It's a function of utility and prices. Expenditure is always a function of utility and prices. So income is equal to expenditure. Expenditure is a function of prices and utility. I just showed you in the above example also. So I can say that this is equal to this, but here, instead of income, I can just put my expenditure function. कर सकते हैं, income और expenditure same है, हमने ऊपर ही prove किया, हर example में हम करते हैं. So I can rewrite this. How, beta? I will say that the compensated demand is equal to uncompensated demand, but income की जगह पे I will write the expenditure function now, since the two are equal to each other. Now, differentiate both sides with respect to Px. So we are differentiating both sides with respect to Px. यहाँ पे तो Px बेटा सिर्फ यहाँ आ रहा है. This is Px. So this will simply be del xc by del Px over. But if you notice, here Px is coming here also and here also. Px is coming at two places. Let's see this mathematically. एक बार समझ लेते हैं. When I have f as a function of xy, and I ask you to differentiate this. Okay, yes, Manish. Which step do you want me to repeat? This one? Okay. So what this is doing is, I said, so we have to understand that there is a point such that compensated and uncompensated demands are equal. The compensated demand is a function of prices and utility, right? Uncompensated is a function of prices and income. Now, what I said is that income and expenditure are the same thing. जितना पैसा कमाओगे उतना ही खर्चा कर सकते हो. So income and expenditure are same. So instead of income, I have replaced this income with expenditure. This is all that I've done in this step. Now I have written expenditure instead of income. But what is this expenditure? So mathematically speaking, if I just look at any expenditure function, जैसे हमने यहाँ derive किया था, income की जगह पे हमने expenditure लिखा. What is this function of? It is a function of utility, how much utility I want, and the prices, Px and Py. Right? So this is what I have done. Instead of income, I have written expenditure and I have said that this expenditure, जब भी expenditure function लिखोगे, it will be a function of prices and utility. So that is why this has come like this. I hope this is clear now, right? So still, I am equating compensated demand to uncompensated demand. दोनों को equal कर रहे हैं. This is compensated, this is uncompensated. And instead of income, I've just replaced it with expenditure, right? Now, utility beta is a numeric value held constant, right? So I'm just keeping it as a numerical form, not functional. Okay, now just think about it. See beta, when f is a function of x and y, and I ask you differentiate this function, so you will tell me how f changes as x changes dx, how f changes as y changes dy. ऐसे differentiate करते हैं. Now, if I ask you differentiate this function with respect to a new variable z, so how will you differentiate it? You will tell me how function changes as x changes and how x changes as z changes. How function changes as y changes and how y changes as z changes. This is applying the chain rule. Function x की या y की वजह से ही change होगा. X and y, z की वजह से change हो सकते हैं. X and y will be functions of z. X अपने आप में एक function of z होगा. Y अपने आप में एक function of z होगा. But function यहाँ पर x and y का है. Right? You will learn this in maths also. थोड़ा सा यहाँ पे we need to apply this. X is a function of px directly. कोई दिक्कत नहीं है. No problem at all. But x is a function of expenditure. Expenditure is a function of px. Chain rule apply करना पड़ेगा. Let's try to differentiate this now. So if I apply differentiation, बहुत ध्यान से, x is directly a function of px. So how x changes as px changes? Plus x is a function of expenditure. So how x changes as expenditure changes? And expenditure is a function of px. So how expenditure changes as px changes? This is the differentiation. You must learn this kind of differentiation even for the next class. Usme I will do implicit functions. Implicit function कौन से होते हैं? In which the function is not defined. यहाँ देखो, I am not writing x as m by 2 px या m by px plus py. कुछ function नहीं लिखा मैंने. I am just writing that x is a function of prices and expenditure. I haven't explicitly defined the function. So this beta is called implicit function. When you don't define the function, जैसे Marshallian में, when I say x is a function of prices and income, मतलब ये Marshallian होगा क्योंकि income आ रहा है. So I know that this is Marshallian demand. But this is implicit. कुछ बताया नहीं ना exactly क्या functional form है. बस इतना बता दिया, it's a function of prices and income. But when I say x is equal to m by 2 px, या x is equal to m by px plus py, तो define किया ना form को, that income numerator में आ रही है, prices denominator में आ रहा है. But this is explicit form. This is also very important. Right? इस केस में implicit differentiation I will teach you in the next class, don't worry. We will again do it. Implicit differentiation becomes important. That is exactly what I have done here. I am differentiating this. I'm trying to understand how it changes as PX changes without defining the form, right? So this is implicit differentiation. Yes, let me repeat the differentiation part again. No problem. So look, see, I am saying I want to understand how the demand changes as price of good X is changing. This is what I want to do. So this, just look at the right hand side. I am saying X is a function of PX and X is a function of PY and X is a function of expenditure. Expenditure itself is a function of prices and utility. So expenditure अपने आप में एक function है इन तीन चीजों. Now, the aim is to understand how demand changes as price changes. Background में ये simple सा aim है. So if you just go back here, I want to understand that supposedly beta price is P1. Price falls to P2. When price decreases, I know that the demand is increasing. ये compensated बोल रहा है कि demand बढ़ेगी. Uncompensated भी बोल रहा है demand बढ़ेगी. The demand will increase. So both compensated and uncompensated here are telling me that when you will decrease the price, the demand will increase. इसको mathematically कैसे देखें? How do I understand that what is the impact on the change in demand when prices are changing? This is what I am analyzing here. I took this point initially when the two are equal. ये point of it. This point. When the two are equal. I've equated the two. And now I'm asking, what will happen when price changes? When price decreases or increases? When there is a change in price, right? That's the differentiation I want to do. This was pretty simple. The left-hand side. PX is only coming here. So when I had to differentiate, यहाँ पे simple हो गया. Del XC by del PX. Done. Now look at the right-hand side. PX is coming here also, this side, this is PY. And PX is coming here also within the expenditure function. So when I differentiate it with respect to PX, is side. How will I do? I am saying how X changes as PX changes directly, direct effect. How X changes as PX changes. That's the first effect. Plus, X can also change when expenditure change. X is a function of expenditure also. And expenditure is a function of prices. So how X changes as expenditure changes into how expenditure changes as price changes. This is applying the chain rule. I hope this is clear now. Right? I can point you to the maths lecture also in intermediate videos. You can have a look there and you will do it in maths. Don't worry. But this is required for our part. So try to understand how X changes as PX changes plus how X changes as expenditure changes into how expenditure changes as PX changes. Right. Now, but from here, I will keep this side and take this here. So I will get del X by del PX is equal to del XC by del PX minus del X by del E into del E by del PX. Try to understand this. was the Marshallian demand. So X is Marshallian demand. X is also called as uncompensated demand. X also represents ordinary demand curve. So beta, this tells me how the ordinary demand or the total demand, ordinary demand curve तो यही था ना, uncompensated demand तो total demand curve था ना, total effect दिखा रहा था ना. So this tells me how the ordinary demand will change as price changes. That means this tells me how the total effect will be. Total demand कितने से change होगी? When the price will change? This is basically this effect, this side. This is the total effect. Right? Now look at this part. This is XC. XC was the compensated demand. It was also called as the Hicksian demand. From our last class, we know that the compensated demand is only showing substitution effect. So this part is my substitution effect. Right? We know total effect is substitution effect plus income effect. यही तो दो effects होते हैं. So this entire part with the negative sign, this becomes my income effect. So I can say that this part, क्योंकि बाहर plus sign होना जरूरी है. So negative has to be taken inside. So I can rewrite this somehow. I can say plus, I can just put minus here. This part, this represents my income effect. We have decomposed the total effect in Slutsky into the Slutsky equation, or the total effect, into substitution and income effect mathematically. We had only done this diagrammatically in the previous classes, but now I have been able to do this mathematically also. यही हम यहाँ दिखा रहे हैं. This is a mathematical analysis. Now, let's just take one more step here. Just think about this. Expenditure is nothing but price of good X into the units consumed. यही तो expenditure है. If I am buying 4 units of good X, each at 10 rupees, I am doing an expenditure of 40 rupees. So expenditure is X into PX. From here, can you tell me what will be del E by del PX? If I differentiate with respect to PX, it means I will hold X constant. So iska differentiation will only be X. Right? That's the first thing. Second, we know that expenditure is nothing but income. Right? Expenditure and income are same. So in your books, when you will go and see this equation anywhere in the book, the equation you will see will be like this. Del X by del PX is equal to del XC by del PX minus, instead of expenditure, they would have written income. And instead of this, they would have simply written X. Instead of this, they would have written X. This is the equation of Slutsky that you will find in the book. This is the final version of Slutsky. Try to analyze this income effect. क्या बोल रहा है ये income effect? This says the following. Whenever your price will increase, suppose your price increases, it means that your expenditure on that good will increase. It means that you will be willing to buy less of the good because it is becoming expensive. So when price will change, it will change your expenditure, or it will change the amount of income you spend on the good. And when that will change, automatically it will affect the demand of the good. So there is a version of the demand that passes via the expenditure route. Yahi to ye bol raha hai. When price will change, the expenditure on the good will change. The expenditure on the good will change. And when the expenditure on the good will change, it will change the demand of the good. Right? So this is this income effect decomposed. Prices affect the money I spend on the good, the expenditure on the good. Expenditures affect the demand of the good. This is my income effect. Now, look at this negative sign. Okay, let me take it down. Equation of Slutsky. Okay, let me show it again. But this itself is the equation of Slutsky. This is the final equation. And this is just one version back. Just you can make a note of both of them. And just make note that this is total effect, substitution effect, income effect. These are the two equations of Slutsky. Okay. Let me know once you have written this. Done? Fine. So let's write down this income effect decomposed also. So please write down first of all, income effect. It reflects how price of the good affects demand of good through necessary changes in expenditure. How price of good affects the demand through changes in the expenditure. This is what it tells, right? Now, one last thing is, why is this negative sign coming? Is negative sign ka kya matlab hai? Many students ask. So just think about it. When price of good X increases, it means that your real income decreases. It means that demand of good will decrease if it is a normal good. So through the income, we see that price and demand of good move in the opposite direction. Price increases the expenditure, increases the income, which in return decreases the demand of the good. That's one way of looking at it, right? There is another way. When your price increases, your real income decreases. Now, if you want to afford the original bundle, what do you want, beta? The original. So if you remember, जब हम Slutsky को substitution और income effect में divide करते हैं, तो substitution effect क्या कहता है? Holding income constant or holding utility constant. So if I want to go ahead and afford the original bundle, then what should I do? I should give income to the consumer. I must give some money to the consumer if he wants to make his original bundle affordable, right? So for analyzing the substitution effect, I must give some income to the consumer if I want to analyze that. When price of good increases, I must in a way give income to the consumer, right? Similarly, if you remember, just see this diagram. Suppose this is the initial equilibrium point, point E. Let's say the price of good decreases. I move to the final bundle here, somewhere here. This is point E dash. When I want to analyze the substitution effect, even via the Hicksian approach, let's say, what do? I go back by holding utility constant at the new prices. So beta, I am shifting backwards now. I am taking some money back from the consumer so that he can go back to original level of utility. I am shifting his budget line inwards, taking his income away. So when price of good increases, to get the same level of utility, in a way I must give more income. ये बहुत important है for analyzing the effects that we do in the next class also. So when price of good is increasing, in a way I must give more money to the consumer if he wants to get the same level of utility. And when price of good decreases, he can get the same level of utility even after I take the money from the consumer. Very, very important, right? This is important for compensating an equivalent variation. So let's write this down, that when price of good decreases, to attain same level of utility as before, consumer requires less amount of income. Same utility, पुराने IC पे utility पाने के लिए अब मेरे को कम पैसा चाहिए क्योंकि चीजें सस्ती हैं. Things are less expensive. Things are cheaper. So with less money, I can get the same level of utility, right? So you have to understand this concept that price and income move in the same direction. If price decreases, I will need less money to get the same level of utility. Two important points. Please make a note of these 2 points also. Right? Okay. Now, this is a very heavy class, so make sure you revise this multiple times. I want to also prove non-positive nature of substitution effect. Multiple times we have made this table. in which we did SE, ऐसे किया था. We went ahead and we did it for normal goods, inferior goods and given goods, substitution effect, income effect and total effect. And we were saying that price of good X is decreasing. So substitution effect says demand will increase, increase, increase. Income will say increase, decrease, decrease. And total will say increase, increase, decrease. Multiple times हमने किया. And throughout, we showed that substitution effect is negative, which means it moves in opposite direction. इसी चीज को, in the last class, we wrote down that compensated demand curve is always negatively sloped. We proved this. Uncompensated या ordinary demand positively sloped भी हो सकती है, negatively sloped भी हो सकती है. Compensated हमेशा opposite direction में ही जाएगी. Right? Substitution effect will always be non-positive or negative. I want to prove this mathematically today. So, to do that, please start by saying that suppose there are two bundles. The first bundle is C and the second bundle is D, right? This bundle C is showing the demand of good X and Y, and D is also showing the demand of good X and Y, right? These are two bundles. And consumer is indifferent between them. Which means that the consumer thinks that he gets the same level of utility from the two bundles. He is indifferent between the two bundles. Now, suppose I tell you, देखो indifference का मतलब ये नहीं है that there will be same price ratio. समझो बात को. Suppose ये एक indifference कर रहा है. This is bundle C. And ये XC है, ये YC है. This is bundle D. This is XD, YD. But if C has to be the equilibrium bundle, तो tangency C के through होगी ना, ऐसे होगी ना, whatever C point is, this will be your tangency. ये budget line होगी. तो budget line को मैं interconnect कर दूं. Let's make this as the budget line. If D is the equilibrium bundle, suppose, तो tangency will be like this. ऐसा कुछ होगा, right? The budget line will be different. So if C has to be equilibrium bundle, अलग price ratio चल रहा होगा. अगर D equilibrium bundle होगा, अलग price ratio होगा, क्योंकि budget lines have to be tangent. There are two different budget lines, right? So this implies that there are different prices at which the bundle can be the optima bundle. So I can say that let PXC and PYC let these be the prices at which bundle C is chosen. And PXD and PYD, let these be the prices at which bundle B is chosen. दोनों अलग प्राइसेस जिसपे C और D को चूज करना है. अब नेक्स्ट चीज देखो. See, when C is chosen, जब हमने C को चूज किया, This is the budget line, beta. Note that D is unaffordable. D तो affordable ही नहीं है. D outside the C's budget line lie कर रहा है. Right? So when C is chosen, the budget line is this. This is my budget line. D is outside that budget. D is not even affordable. So when C is chosen, D is unaffordable. उस prices पे D बहुत expensive है. So the prices at which C is chosen, उस पे जो हम C पे expenditure करेंगे, that will be less than the expenditure I do on bundle D. Here you can go ahead and write C. This is the expenditure on bundle C at the prices of C. This is the expenditure on bundle D at the prices of C. Sorry, here you will have C. So इस price ratio पे जो PC, PCX and PCY है, D is unaffordable. So let's write down. Bundle D is more expensive than bundle C at the prices PXC, PYC. Is price. Similarly, look at the next. When I choose bundle D, मतलब यहाँ पे है, ये price ratio है. This is the price ratio, बेटा. Then C is unaffordable. C तो affordable ही नहीं है. So when D is chosen, C is unaffordable. C पे खर्चा बहुत ज़्यादा है. C is more expensive. It is outside my budget. Budget line से बाहर है. ये budget line है. Outside my budget. So we can say that when D is chosen, what prices? PXD, PYD, C is more expensive. Right? How do I show it's more expensive? इस price ratio पे PXD, PYD, bundle XDYD is less than PXD, PYD, bundle XCYC. These are the two equations that I have written. Now you just have to rearrange these equations. So if I rearrange this equation, what can I do? I can just take this here and I will get PXC, XC minus XD plus PYC, XC minus YD less than equal to 0. ये equation है. Similarly, I can rearrange this equation. So I can just take this here, and I will get PXD, XD minus XC plus PYD, YD minus YC less than equal to 0 by rearranging these two equations. No. Case of perfect substitutes. Weak inequality means there might be a case that the two are exactly affordable. Maybe your D lies here. Okay, so you're saying in terms of IC, yes, you're right. Then my IC will be straight line. It will be perfect substitute. Correct. That's correct. Okay. Okay, so I have got these two equations now. This is the first equation. This is the second equation. बेटा ये देखो ध्यान से, यहाँ पे भी XC minus XD आ रहा है. यहाँ पे अगर मैं नेगेटिव साइन बाहर ले लूं, suppose I take this minus sign out, then this will also be XC minus XD. है कि नहीं? यहाँ पे YC minus YD आ रहा है. If यहाँ पे YD minus YC आ रहा है, so if I take the negative sign out, this will also be YC minus YD. Right? Which means that ये दोनों equations में जो ये part आ रहा है, this is the same. YC minus YD, YC minus YD, XC minus XD, XC minus XD. So what I will do is I will add ये equation 1 दे देते हैं. This is equation 2. I will add 1 and 2 together. So when I add this and this together, इसमें ये वाला part तो common हो जाएगा, XC minus XD, XC minus XD. So what will I get? I will get PC PXC minus PXD, XC minus XD plus PYC minus PYD, YC minus YD less than equal to 0. This is what you will get by adding the two equations together. Okay. Please revise this today itself. This is very difficult. Slutsky is one of the most toughest chapters. इसको revise करना बहुत जरूरी on the same day. So you will get this equation. Now tell me something. In economics, whenever we do Slutsky, एक टाइम पे हम सिर्फ सिंगल प्राइस चेंज करते हैं. मतलब जब हम प्राइस ऑफ गुड एक्स को चेंज करते हैं, हम वाई के प्राइस को कांस्टेंट होल्ड करते हैं. वी होल्ड इट कांस्टेंट. एंड जब हम प्राइस ऑफ गुड वाई को चेंज करते हैं, तो हम एक्स को कांस्टेंट होल्ड करते हैं. सो विच मीन्स दैट इफ आई वांट टू एनालाइज हाउ प्राइस ऑफ गुड एक्स इज चेंजिंग, आई शुड ideally be holding price of good Y constant. That will give me a better analysis. Yes. This is equation 1. This one. How we added? Okay. Note this beta. I am adding equation 1. This is equation 1 to equation 2. This is equation 2. So if you add these two together, what will you get? You will get this P XC XC minus XD plus ये वाला part आ जाएगा minus PXD XC minus XD प्लस ये वाला पार्ट आ जाएगा PYC YC माइनस YD, फिर ये वाला पार्ट आ जाएगा. सो प्लस माइनस PYD YC माइनस YD लेस देन इक्वल टू 0. सो आई हैव एडेड दिस टू दिस. राइट. सो दिस इज माय ये वाला पार्ट. देन आई एम एडिंग दिस पार्ट टू इट. देन दिस पार्ट. And I'm adding this part to it. Now, if you notice, here I can take XC minus XD common. That is what I've done here. XC minus XD, and you will get PXC minus PXD. Plus, you can take common YC minus YD, and you will get PYC minus PYD less than equal to 0. Right? So this is how we have got this equation. Okay. Now, so I was saying that you have to hold one price constant. So if I hold that price constant, what will happen? I will say that let PYC be equal to PYD. That means I'm assuming no change in price of good Y. ये 0 assume कर लो. No change in price. Why? Because at a point I just want to analyze changes in price of one good. So what will I get? I will get PXC minus PXD, XC minus XD less than equal to 0. ये हो गया change in price. ये हो गया change in demand less than equal to 0. When is the product of two things negative? When one of them is negative, तभी तो product negative होगा. So suppose I want the product of two things to be minus 20. बेटा 4 into minus 5 minus 20 हो सकता है या minus 4 into 5 है ना. So if I want the product to be negative, it implies that one of the two is negative, right? It means that they are moving in opposite direction. अगर ये पॉजिटिव होगा तो प्राइसेस फॉल हो रहे होंगे, अगर ये इंक्रीज हो रहा है तो ये डिक्रीज हो रहा होगा, अगर ये डिक्रीज हो रहा है तो ये इंक्रीज हो रहा होगा, बिकॉज द प्रोडक्ट इज नेगेटिव. आई हैव प्रूव्ड इट. So it means that they are moving in opposite direction. Yes, Divya. So what we are saying here is that, so from here, if you notice that I took this to be 0. I said prices of good Y are not changing. So when price of good Y is not changing, I said that this is 0. And I just was left up with this. Now, this is the difference between two different prices. So I'm saying this is the difference between prices. Change in the prices. Change in price. Difference between two demand. Change in demand. And I have this sign that this has to be less than equal to 0. So less than equal to 0. So I'm saying the change in prices into change in demand is less than equal to 0. The product of two things is negative only when they have opposite sign. तभी तो negative होगा. So if this is positive, this must be negative so as to make the product negative. And if this is negative, this must be positive to make the product negative. So price and demand, they move in opposite direction. This is exactly the substitution effect. When price increases, demand decreases. When price decreases, demand increases. Now you will ask me, substitution क्यों? Why not total? ये substitution ही क्यों है? Why is this showing substitution effect? Because beta, we assumed that both x's are on the same indifference curve. We assumed they give you the same level of utility. You were indifferent between the two. And when you move along the same indifference curve, that's the substitution effect. So we can write that since C and D are on the same indifference curve, movement from C to D or vice versa, when price changes, can only show substitution effect. Please revise this. This is very, very important. बहुत important है ये. So C and D are on the same IC. They are on the same IC. The only thing that changes is the price ratio. यहाँ पे prices ये थे, and prices have now changed. But I am moving along the same IC, na? It means I'm holding utility constant. So it cannot show total effect. It must show substitution effect. So change in this X, the gap between moving from C to D, this only shows substitution effect. And substitution effect, so this is substitution effect. and prices का product has been proved to be less than 0. It means that they are moving in opposite direction. So when the price of good X will increase, substitution effect proves that the demand of X will decrease. Only substitution effect. We are only talking about that. So what have we proved? Mathematically, we proved the non-negativity or non-positivity or negativity of the substitution effect. Yes, we are doing it via the Higgsian approach. You're right. Okay, most of the things we will do for Higgsian only. Jo bhi compensated compensation variation, equivalent variation. Most of them I will assume utility constant. So this is what I wanted to do today. Please revise this before the next class. I'm still left up with some topics from Slutsky, which I will try and complete in the next class. Now that we have done a significant proportion of Slutsky, I think you can now do some assignments on Slutsky. Shuru mein, we were just doing the graphical approach. So today I will post some assignments. Please do those assignments. Also, I will keep some midweek tests because we're lagging in the topics in the test, right? So I want to do more tests. So in this week, within the week, maybe 2 or 3 more tests will come. Please do those tests before, we start with intertemporal. Yes, it can be horizontal. You're right. Okay, thank you.